Hello everyone and welcome to class. In today's class we'll talk about software development security. So this is domain 8 and this is the last domain for the CISSP domains. So if you've not followed the domain, just go back and follow domain 1, domain 2 up to domain 8. It's so essential to understand the CISSP domains and what it's all about. Alright, in this domain 8, we're going to be looking at some specific things. Basically, this domain is focused on building security into software right from the very beginning. So, the focus of security is don't put security like an icing on the cake. It has to be baked into the cake from the very beginning. And that's the essence of what we're looking at security from the very beginning. So it's easier to be able to defend your software once the security has been placed in from the beginning. Because what most people do is to place security after they've already built the software. So it's more like just doing it like an icing on the cake. And that's not what we really want to do with this domain. All right. So in this domain, we're looking at the software development lifecycle. We're looking at security and operations. Then looking at disposals. So it's more like the whole life cycle of the software. So I call it the security life cycle. That's total life cycle that a software has from the conception till the disposal, to the maybe when the software is ending up. So in this, like I said, we're breaking into three SDLC, software development lifecycle, operations and improvement, then also disposals. So from the software development lifecycle, we're looking at it, which is the different stages. I think there are about 5 stages. The first one is the planning stage. So the planning stage talks about from conception of the software. So just look at it as a very simple analogy. Like when you are trying to build a house, so the first thing is to have a plan of what you want to build. Then you are able to have the cost estimate of what you want to build. You do some analysis, basically, just like business do some analysis. You try to see what requirements do we need, what is essential, what's not essential. Then you go through all of these things while at the planning stage, so you can easily know what it will be, what you're going to cost. It's going to cost you from the very beginning till the end. So the planning stage is very essential, and if from the planning stage you really even know if there's a need for the software or if there is not. So sometimes in the planning stage you could also do some market survey, market analysis to see this software we're trying to spend a whole lot of money on. Is this something that the market needs at the moment, or is this something that is not needed in the market? So all of these are, I feel the planning stage is so essential because at this stage you are able to really have an idea of what the software is meant to do, the process of the software, the process of security in the software, and also the lifespan of the software can also be discussed all at the planning stage. So the next thing we'll look at now is the design stage. So at the design stage here, we are looking at basically a concept of a design of the concept rather. Like I said, it's like you're building a house. So now it depends on the kind of house you want to build. If it's a bungalow, there'll be a design, a plan. Then there'll also be this kind of design of it. If it's a maybe 4 bedroom detached, you also, so you can really see it, the design from the very beginning. You can have a look, or whether they put it on a paper or put it on a box or whatever it is. So you can imagine and see the very end from the beginning. And this is what precedes the eventual development. So it has to be a structure in place that the development guys are going to use to start off their work. then you can now start knowing how many cement they will need and all of this kind of thing. So I'm just trying to bring it down into a very practical way that you can see this thing is the same thing when it comes to building a software. So building a software, you need to have a plan from the very beginning. Then there needs to be a design. You need the design team, maybe the UI UX guys and other people in the design team to be able to give you a perfect design of the concept, so that it is once the design has been approved, the plan has to be approved by the management, plan has to be approved by the management, then next the design has to be approved by the management before development can begin. So we've always said it that for people who do a freelance work, most times it's always their clients don't go through all this stage, because just here, hello guy, I heard you do web design, I heard you do web development, or give me an app, and they tell you this is my budget, this and that and that. So it's very imperative. I know many of you just like to just build something from your head, just like to have a design, a concept in your head, and just try to build. The person explains to you, this is what I want, this is what I want, this is what I want, shows you one or two samples, then you are good to go. But on a standard way, you don't build that way. You have to be a design first, then it's the design that they will approve, and once they approve the design, you can build, right? So that you don't have to start doing, after you finish building, the person says no, something is missing here, then you have to start all over again and stuff like that. So if the design is approved, then you can move on. But nevertheless, if there's anything the person detects as an issue, the design has to be edited and approved again. So that process makes it more, yeah. With that process, at least you're able to get a standard result. So, and that's the process that companies actually go through to have a software being developed. So our own focus really here is the fact that we want security to be even from the very much design stage. From the design phase, there has to be security implemented throughout, from the conception design stage. We have to think about security. What security policies are we following? What security principles? What security frameworks? And all of that. These are, and security controls are going to be in the software from the very beginning. And it's very, very easy once you start off with security at the beginning. Once you put security at the end, or you put security like an icing on the cake, then obviously there's some things that will not be looked at. And even though you try to test at the end, you still it might pass, but there will still be some bugs that are not unnoticed, and there will be some security flaws that are unnoticed, and that could be a vulnerability for the establishment. So we can move right there into development stage right now. In development stage, we are looking at following the design completely, and then we're talking about writing codes, and then now even at the stage of planning, we can plan to know what type of code are we going to use. Are we going to build from the scratch, or are we going to maybe buy an already existing code and edit it, or are we going to use a maybe like things like WordPress, or maybe whatever it is. But for software, you have to plan what you want to use. Maybe you're buying a code, build it from scratch, or whatever it is. So all of those things will determine how the development phase will go. So if you're building from scratch, obviously fine, you need to have your developers on ground, and they will actually start off with building based on security policies, security controls, security principles, and all of that, and which is so essential as a security analyst. Okay, so during development, we are looking at using different security controls, and also testing the controls through different means like penetration testing, vulnerability scanning, and checking if they pass through well-defined standards for security and security requirements. So we also need to identify potential threats and vulnerabilities very early in software to see that we are not missing anything. So secure coding practices that we can actually use is the first one is you can do an input validation, which is a standard. Make sure that you just imagine and assume that your users are not going to do or are criminals in the real sense of the word. Let's imagine that all our users are potential criminals in the sense that if we tell them to type numbers, they might not type numbers. They might just try to inject a code to be able to see how they can be able to get into the database. So if you think about the fact that there might be a portion or percentage of the users that are criminals, then you need to use an input validation that every input is validated, and then whatever is not supposed to be an input is supposed to be removed or not allowed. Then output encoding prevent data from being misinterpreted by encoding before encoding it. So all those things also need to be looked in. Then there has to be a proper error handling. Error handling needs to be properly done to prevent leakage and also prevent security vulnerabilities. So these are the parts of secure coding practices. We need to ensure that error is handled well. So if any error comes, like for example, for database, there used to be this database connection error, failed to connect to database. So we don't want the fact that once there's an error, the bad guys or the threat actors can be able to see what the error code is itself. So if they can be able to see the error code, at least it gives them an insight on what the problem is in the database. So from there, they can now begin to think of how to manipulate it. It's just like there are different layers to security. So if they can pass one layer, beneath the second layer, this is exactly what we want to look for. So there are many ways. There could be also ways where an error could be interpreted in a way that only developers could understand. So rather than just writing maybe error 503, which means this and this, they could be able to write something else that the developer understands that okay, this is the error that's coming up. So because an error can be hijacked and can be easily interpreted by a threat actor to know the exact problem going on in the database. So also we need to talk about authentication and authorization. We need to implement secure authentication and authorization mechanisms. So while the development guys are working, they need to be secure authentication, that's both identifying and verifying your identity, and also authorization mechanisms need to be done properly. So we also advise them to use a multi-factor authentication so that they can be able to ensure that the real person behind, or the person who claims to log in, who wants to log in and claims an identity, is the real person behind the identity. Then we can look at session management. So in this place, every login has a session, and there's a session for every login, and the time you spend on server, your dashboard. So basically, if you log in after some time, depending on how the session is, if there's an inactivity, there could be a session, your session out. So yes, you really understand this if you really log into an app. Sometimes when you log into an app, like after 10 minutes or 5 minutes logging in, it's called that if you don't do anything to log you out, you have to log in again. All of these things are just secure practices where they ensure that in case the person who claims to have the identity is not a real person and is logged out, the person will have to start thinking of how to be logging again. So yes, sessions should not be hijacked. It should be a way to protect user sessions from being hijacked. Then cryptographic practices too is a very good way. That's we are actually seeing how we can encrypt information or data that passes through. Encryption of data is important so that the threat actors or the bad guys will not be able to view and be able to see the data. Another thing we can do in the development stage is to make sure that we test for the applications, and the application can be tested. So because once we finish developing now, we can now do testing. But right in the development stage, we can still do some testing. We can just test through by using the static application security testing, or SAST. So that's you analyzing your source code for any vulnerability, just checking through. That can be done by maybe a senior developer or someone who is um, very familiar with the development process. So the person could be able to just get through, look through the codes to see if there are any coding practice that is missed, to check the input validations, to check if there are any flaws, vulnerabilities, or mistakes, or places that are not covered. The person can just check through. Whereas dynamic application security testing is when the app is live, you checking to see if there's any misbehavior, whatever it is, misconfiguration, whatever it is. So once the development stage is done, then proper testing can begin. So proper testing, now we can start with security testing like penetration testing, using bug suit or whatever you call it. Bug suit could be very essential. You can be able to test security easily, then do penetration testing. You are able to simulate a real world attack to test if the controls are very effective. Then there are many code reviews that you can also do. Check through, check through, check through. You can't over check through because every software always have a bug. Now it's time to deploy the software. Once we are able to check that this software is not having bugs, then you can now deploy the software. In deploying the software now, we can look at before giving it to the general public, you can look at giving it to a smaller group of people. So that is called canary release. Canary, Canary, canary release. It's done by companies, even big companies like Google or Microsoft. They do a canary release where they release it to a small subset of people to test it and to see the performance, to see how it works. So once they do it and test it and they give feedback, whatever feedback they work on it, and they keep doing that. So once they are certified that this thing is good to go, yeah, they are able to deploy. So you can deploy and then put it on the web, so that on maybe if the software on the web, or you can put it on the web, and if the software that needs to be put in Play Store, you can just put it in Play Store, and then people start downloading and checking up how the software is working. Another thing now is to after deployment has been done, another thing to now do is to ensure that you use the right methodology in software methodology. So, but before we talk about that, let's still talk about supply chain security. So most times, some softwares, or almost every software, really also work with a third party for some things. For example, there could be some third parties that could be useful when it comes to payment. Like most software don't develop their payment system themselves, so they could rely on third party, like maybe the Flutter Waves, the Paystack, and all of that. And you must also be careful to ensure that the third party actually uses the same level of security framework and policies, and are always up to date with their security, so that they don't become a vulnerability for your own organization. Because if, for example, the company that is your third-party software provider decides to doesn't take security very seriously, and they have a vulnerability, or they get attacked, or whatever it is, now that could be a very big problem, and you will not be able to explain to your users that it is a third party. You can't be telling your users now that it's a third party that caused it and stuff. They won't listen to you because they actually signed up with you and not the third party. So you must also be very careful of that. And when it comes to open source softwares, Yeah, you generally know that open source codes are kind of lesser risk because of so many developers are working on the software at the same time. But nevertheless, we must also see how we can manage the risk that comes with open source. So once we are able to do our canary release and want to release to the public, then we need to know what form of methodology is the best for our development. So let's look at that. People use many forms of methodologies, but the most popular remains waterfall, agile methodology, and DevOps. So waterfall is more like a very simple and straightforward form of methodology. That's when we can look at building phase by phase without any plan to change the codes or whatever it is. So with waterfall methodologies, from the word waterfall, it's more like water falling down the hill. So if we get the concept, like water falling down the hill, so it's more like it's very easy for water to fall down the hill, but it's difficult for it to go back uphill. So waterfall is more like it is for companies or organizations that already have a well-defined structure of how their software will go. So maybe companies that have a lot of requirements and approvals, and so everything that is built on well-defined structure and layer. So they're not really things to edit and to roll back like that. So that's when you can talk about waterfall. So waterfall is not as used as before because it's very straightforward and you build phase by phase by phase. And once you finish one phase, you complete and move to the other phase. So, but instead of that, people prefer to even use a waterfall. Modified waterfall. Modified waterfall means you can even still roll back to the former phase in case there are stuff that you need to work on. But instead of that, people decide to use agile. So agile methodology is another one that is getting popular, especially used by project managers today. For project managers, agile methodologies can involve different names and different concepts. Like you could have Scrum masters, and they could have that's the facilitator of the project and all of that. So in agile, it's not like waterfall where you don't edit. In agile, you can do editing. You can, it's more like they are building an agile system. Let me just say the word agile system. They produce, they develop a little, they release to the public. People, they see people's review, they work on it again, they keep working like that. So they use feedback to work on it, they move. So it's not like they're not building it like a well structured from the set of template that this have to follow this kind of pattern. So in agile it's more very dynamic, and you could have facilitators that work on the project, the project managers, and these people could be able to have daily meetings. And even agile actually brings collaboration a lot. Team can collaborate on the best way to move a project forward, idea collaboration, all of those things. So agile is also very useful today. Then the last one is DevOps. DevOps is kind of very popular. And in DevOps, you could also use security from the beginning to the very end. So that's what we call about the DevSecOps or the Sec DevOps. Now, with DevOps now, you have someone who is well versed. A DevOps engineer is someone who is very versed in at least cloud, in web, in software development, in cloud, and even in operations. So DevOps is a combination of development and operations. Development and operations. So the person who oversees development phase is able to oversee it with development guides and also oversee operations now, because here we're looking at operations has a whole lot of work to do also. So we're looking at cutting costs using the best way to reduce operational costs, effectiveness, performance monitoring, all of those kind of things. So for DevOps, they use a lot of CI/CD, continuous integration and continuous development. They use a lot of stuff to be able to make their work effective. So our focus is security involved, because in DevOps, there is security at the beginning, security at the middle, and security at the very end. So that is it. Then we talked about theory, divided into theory. We said the first one is software development lifecycle, whereas the second one is operational management. So, like I said, operations, even from the part of the operations in DevOps, operations you are looking at, just take an example of a woman that is pregnant. Yeah, from conception to delivery, period of 9 months. Yeah, just like the developers are working on this thing. Yeah, good. Conception to delivery, development. So, but once the baby is born, that is not where the job ends. There have to be a job just begins from there. So there has to be ongoing maintenance. For example, there has to be maintenance. There has to be maintenance, fixing of bugs, releasing of updates, ensuring the software works correctly and functionally. Then there has to be things like performance monitoring. You have to monitor performance to see um, and track the software to see that it's really doing what it says it will do. There have to be things like user support, where users are able to be helped once the program is out, to be able to help with so many parts that they need and gray areas they need help and all of kind of things. So also enhancement features, they have to be, we have to sit down and discuss on what features are we going to add, what are people complaining of in customer feedback, what features are we going to work on and all of this kind of thing. So the operation side is where like the real work comes in. So once the operation kicks off and then you gather data, you're able to now start off the cycle again. So it's a software development life cycle. So a cycle of a new release has to start all off from the beginning again, from planning to all of those kind of things again. The cycle has to move all over again, planning to design and all of those kind of things. So for every update, there has to be a new cycle coming up and all of that. Then disposal. So yes, softwares can get to retirement phase. You can retire a software. Companies do that a lot. Big companies do that a lot. Google do that. Microsoft does that. All of that. So you can start to retire a software. For example, Microsoft has told us that Edge is going to take over Internet Explorer. So Internet Explorer is being retired, so they can retire his software. Once you retire his software, there's a process to retire his software. There's nothing bad in retiring software. You can retire software, but there has to be a process to ensure security, because the concern of a cybersecurity analyst is that security operation is done. Security is done in every stage. So security here now is we want to make sure that there's a real planning for the decommissioning of the software. There has to be a maintenance of data, like migration of data rather. We have to migrate data to the new system. So people's data must not be lost in transit. People's data must not be hijacked. People's data must not be manipulated. Their data must be safe and secure and moved to the new system. Then there should also be secure destruction of erasing of the data. So the data must be securely destroyed or erased. If there are hard drives or whatever it is, it must be destroyed securely. It must not be tampered, so it must not be hijacked, and then going to be disposed properly. All right, so that's the most you will take on this wonderful domain 8. So I believe you've been able to enjoy all of the domains, domain 1 to 8. Go back and check it, and then for yeah, there's a quiz question attached to it, and check the dashboard and test the quiz. Have a wonderful day.